My session follows on from Sean's very directly, so there'll be a number of occasions where I'll just skate across things he's referred to, and there are other places where I'll be reinforcing what he was saying. Now, by the nature of what I'm talking about today, this is somewhat of a laundry list, and it's by no means complete. If it were to be, we'd probably need a good couple more hours than I've got. So I'm going to try and skate across a number of areas where I'm going to really point you to other sessions that go into the material in far more detail. So anyway, we'll start working our way through some of the kernel enhancements. As it says, pointers to other sessions, both today and tomorrow. I have a couple of things at the end where we're talking about hypotheticals, ideas we have, things we're working on that aren't necessarily going to be part of Longhorn, and I'll make sure that I call that out very clearly when we get to those, so as not to set unreasonable expectations for you. So as Sean called out, we're very much focused on moving towards 64-bit, okay? Basically, Longhorn server will be our last 32-bit server release. He mentioned R2 in the same way that Server 2003 has an R2 release that many of you are probably already familiar with. Longhorn server will have as well, and that will be our first 64-bit only server release. It's very important that you kind of understand that, and as we talk through some of these things, everything that you've got used to around 32-bit is going to go away over time. And why are we doing this? Well, clearly, as you're all familiar, almost all processors that you can buy today, and certainly we believe everything that's enterprise server class in the 2007-2008 timeframe will be 64-bit capable. So the focus around keeping 32-bit support in doesn't really make much sense to us, we believe. So again, as Sean also mentioned, unsigned 64-bit kernel drivers will not load on Longhorn server. Now, for those of you developing drivers, you're already familiar with this. If you follow any of the online news groups, you've seen some lively debate on the subjects around driver signing. Yes, I know it's hard and it's frustrating, but a lot of the thinking behind what we've been doing with Longhorn server has really been around reliability, availability, serviceability, and security. And this is one of the things that we're doing. I'll speak to a number of others as we go through this presentation that are focused on securing the platform significantly more than we have in the past. It's a very, very big deal. So our old friend, the unsigned driver pop-up, is no longer your get-out-of-jail-free card on the 64-bit systems. It just won't work. I've provided there a link that actually sends you to the driver signing white paper page up on the Microsoft.com. We also have a session there, the introduction to the WDK session that I point to there, which talks in great detail about driver signing and what exactly it is that you need to do. Many of you, I'm sure, are already doing this and are familiar with it, but everybody needs to become aware because otherwise you will have issues. So, what else are we doing in the space around security? Well, some of you will be familiar with PatchGuard. It originally shipped with Server 2003 SP1 64-bit editions. It's designed to catch things like malware, rootkits, the various nasty things that hide themselves in the bowels of the kernel. And what it's looking for are various critical structures, as you see called out there, that are getting changed and that shouldn't be getting changed. Now, for most of you, this isn't any particular issue. Okay? You are unlikely to ever see this, but we do know that there are some people writing drivers that do some very, very interesting things. And it's quite likely that if you do those same interesting things on Longhorn server, you'll actually bug check. Okay? Now again, if you go and have a look at a link which I've got at the end of the deck, there's a couple of papers up on Microsoft.com that describe PatchGuard, and it's already out there today. So again, you can find out whether your drivers cause any interesting reactions when you run them on Longhorn. So, moving into some other things that are near and dear to me, the how. So one of the big things we decided to do, both for Vista and for Longhorn server, was to finally dispense with the uniprocessor HAL and kernel. Now, Sean again mentioned a little bit about the fact that everybody's going multi-core. Obviously, we've had hyperthreading around for some time from Intel processors also. It really didn't make any sense to us anymore to support uniprocessor configurations. So consequently, the uniprocessor HAL has gone along with the kernel. Now this, for those of you who worry about things like the OPK, and the ability to migrate a system from one platform to another without having to go off and completely recreate it, will actually make your lives simpler because there are now fewer howls to worry about. We know from PSS calls that a lot of people have fallen over this in the past, so although it's a kind of an unintended benefit side effect, it is something which will improve things around this a bit. We're also removing support for non-ACPI howls. Now that should be of no issue at all for anybody focused on the server space. There are still a few client systems out there which are doing strange things, as we've seen with Beta 2, but we've been requiring ACPI support since 1998. Hopefully that doesn't cause any of you any grief either. The other thing that's gone away for Longhorn is the HAL kit. This has been of interest to a very small number of OEMs in the past, but has become a surprisingly heavy maintenance burden for us. So for Longhorn Server, it actually goes away now, and we have been working with the OEMs that effects. So for most of you, it's of no real issue. For any of you who've played with either Longhorn or Vista, you have doubtless come across the new boot environment, love it or hate it. The history behind boot.ini, arc paths, tinkering around with boot.ini settings in Notepad, all that great stuff has finally gone to history. Now, I'm only going to touch on this very briefly on this one slide. I would point any of you who are interested to the presentation that actually follows this one in room 6B, in which Andrew Ritz will dig into the new boot environment in great detail. Now, as well as changing all of those things around what we're doing in terms of constructing the boot information, the whole boot configuration data story, how we decide what boot options there are for which builds and so on and so forth, we're also mentioning explicitly the support around UEFI 2.0. Now, for those of you who've worked with Itanium systems in the past, you'll be aware of the fact that we boot those using EFI 1.1. And also, you're probably all familiar with the fact that that's moved out of the domain of being sort of an Intel-owned standard into an open body, the Unified EFI Forum. And their first release, which is ratified relatively recently, is 2.0. So going forward, Itanium systems will continue to boot as they do today, using either EFI 1.1 or 2.0, but we'll also start to see on x64 support for EFI-based booting as well. Now, in fact, for those of you who've been interested, you've probably followed some of the lively discussions after the spring IDF, where Andrew stood up and talked about EFI support and Windows in general. The bits that you're getting today on your DVD will actually allow you to boot using EFI. It's something that is definitely not being supported for Vista RTM, but all of the bits are currently on the DVD as of today, deliberately so we can allow all of you good people who want to experiment with this stuff to actually do so. Server will, however, be shipping with full support for EFI for x64, 64-bit only. Okay, this is not going to be supported for 32-bit in any way, shape, or form, but 64-bit, absolutely. We will be shipping that support with Longhorn Server goes out. Again, as I say, the session follows this one upstairs in 6B. Thank you. Okay, native PCI Express support. Now, unfortunately, the talk I was going to advise you to go and see happened in the last hour, which is not terribly helpful. However, please do take a look at the slide deck for it. In the past, you're aware of the fact we've supported PCI and PCIX, but we haven't natively supported Express. Now, one of the big areas of work we've done around both Vista and Longhorn Server is providing full native support for Express. Obviously, as you know, the majority of servers that are coming out and many of the ones that are available today already support X, and Express is becoming wider and wider as well. That just is a bit of a list of the various things that we're supporting. I'll come back to MSIX in one of our future technology slides. It's particularly interesting in that. But many of the things that you care about for large servers, like supporting multiple segments, all the native hot plug supports, the ability to add and remove parts without having to restate the system. Active state power management. As we talk more about power management support in servers, this also becomes more interesting as well. So I'm not going to speak very much about dynamic partitioning. Sean talked about it in a fair amount of detail, so I'll gloss over this fairly quickly. There is actually a session tomorrow afternoon that I'm giving at 1:15 where we talk about what it takes to write a device driver that doesn't break on dynamic partitioning, as opposed to ones that do, which we have seen quite a few already. Just to very quickly reiterate what Sean said, for Longhorn Server, we are providing support for processor, memory, and I will call it legacy I/O, basically I/O APIC hot add support. As you know, we already have hot add memory support in Server 2003. That continues unchanged, but we're adding support for the processors and for the I/O. We're also supporting replace for processors and memory, not for legacy I/O. Obviously, PCI Express Hot Plug provides you with effectively with hot replace support. The thing we're not doing is hot remove. Again, as was mentioned before, this is something that requires cooperation from essentially every device driver in the system and also applications. So it's something that we're not going to do for Longhorn Server. It's definitely on the roadmap, it's definitely something we're considering, but there's no way we can hope to get it working this time. So a very familiar diagram that you just saw, actually it shows it already being partitioned. So what we really have here is we're just saying, so we have this hypothetical system that you would have one processor and memory complex or partition unit as a hot spare. Now that could either be added if you find that your workload grows to a degree that says you haven't got enough processing power, or you can use it as a hot replace in the same way that you would use a RAID 5 spare drive today. So you have the idea of having spare hardware sitting on the platform. The key thing about the replace is that it's really an atomic operation. Different vendors have in the past supported replace operations in different ways. For some, it's treated very much as being a remove followed by an add. One of the key things around the work that we've been doing is that at no point does the OS or any applications running on it see less resource than when it was booted in the first place. This, at the moment, is a bad thing, so we don't do it. Therefore, we're treating a replace as an atomic operation. And it's very important that that be understood. Now, what we have here is like a sort of very limited overview of what I'll talk about tomorrow afternoon in more detail. They're just some of the issues that we are aware of today from drivers we've been looking at that are affected by the replace operation. Add is no big deal. Add works fine. If you're interested in seeing a hot add demo, go and have a look at the Fujitsu stand down on the show floor. They have a nice big 8-way system, which they're currently adding another 4 processors and a whole bunch of memory on demand. It's a nice little demo. Take a look at it. So you see that's actually working today. So memory management, there have been a number of enhancements. For some of you who came to the DevCon last year and saw Landy Wang, who owns memory management on Windows, and attended his 4-hour Q&A after, some of this will be familiar. For the rest of you, these are some of the changes that have been made, specifically around NUMA support. So as you see, we've got things like separate virtual address ranges across each node, per node look-asides. There's some standard things that will happen automatically if you're running on a NUMA system. Otherwise, there are APIs that you can specifically call as a driver writer to ensure that when you allocate memory, you get it from your local node, rather than being scattered across the system. We've also exposed new Win32 APIs for applications to make use of as well, sitting on top of that. Sean mentioned earlier the idea of systems with huge amounts of memory. I mean, clearly, as we say there, on very large Itanium systems, we actually can work with gaps of up to 1 terabyte between memory. I think the biggest system we've currently tested on is a 2 terabyte system. If anybody cares to give us or loan us something with more than 2 terabytes of memory, we would love to prove that it works correctly. We have no reason to doubt that, but for obvious reasons, it's a few bucks to buy the memory for that. So other things that Land has incorporated, much faster large page allocations, the cache align pool stuff. A lot of the rest of it's really around performance tuning and enhancement. Again, a lot of work's been going into that on Longhorn Server to make things go even quicker than it did before. Now, some of you may also be familiar with the work that we've been doing around transactional file system and transactional registry. And there are a number of papers up on Microsoft.com today. So what we now have is a kernel transaction manager, the KTM acronym in there, which can govern operations to both NTFS and to the registry. And these transactions can actually be run from a command line, or you can program them in. So for those of you familiar with transactions, the atomicity, consistency, isolation, and durability, basically the ability to make a number of changes spanning different parts of the registry and then either commit or roll back on failure. So rather than the situation that you may find yourselves in today where you go around making changes, something takes and something doesn't, and you wind up with a system in a sort of an intermediate state, which is usually fatal. Now, with Longhorn, and also with Windows Vista, we have the ability to ensure that these things are atomic in such a way that either the whole lot happens or none of it happens. This is a great thing. So as it says at the bottom, it gives the ability for applications and things like driver installation to actually have a cleanup if something goes awry. Other things that we've been doing in this space, registry virtualization. Again, this is really around trying to increase the robustness of the system, increasing security. All of the things I'm going to talk about to do with the registry now are really tied in with that at the moment. So sometimes apps want to write to keys that require admin privileges. These rights will now go to virtualized keys instead. It's completely transparent to the application, but it basically means that we don't have some of the dangers that have been inherent in the past with things writing where they shouldn't and winding up with a situation that if you reboot the system, whatever was bad is still there and then you're stuck. What haven't we virtualized? Basically, as it calls out on all of this list, things that are, for example, calling from kernel mode. We still trust kernel mode. We trust impersonation. 64-bit applications as well. This is a lot around sort of badly behaved 32-bit apps, or potentially around things like rootkits, that kind of stuff. We also have filtering in place. And for example, things like manageability applications and antivirus applications have long needed the ability to block particular operations. Drivers can install callbacks for these things. We can't support currently modifying parameters or redirecting calls. The no concept of altitudes, we'll see on the next slide, it talks a bit more about this. Many of you will be familiar with things like the file systems and the mini filter driver model that they've created, where they have the concept of driver altitudes. Now, historically, as you know, driver start ordering has always been sort of a bit of black magic. Exactly how you get your driver to start before or after something else has long been a mystery to many people. So one of the things that the file system guys have done with all of their work around the mini filter model is to provide what they call altitudes, whereby you can actually state what order you want drivers to be as an altitude. In other words, what start order they will actually happen in. So now with the new model, we actually have done the same thing around filtering. So we have the concept of the layered model with altitudes for callback registration, so you can make sure what order these callbacks will actually run in. The altitudes that you request, you need to actually register them with us so that we don't wind up with conflicts. Obviously, an altitude model is all very well till everybody picks the same altitude. We can modify parameters and redirect calls, and we support monitoring, blocking, and modifying. This new model is still compatible with everything that exists already, but obviously that won't make use of things like the altitude aspects, and it falls into the first come, first served semantics. Okay, so service hardening. Why are we worrying about this? Well, again, lots and lots of services exist today. It's a very popular way for people to provide some kind of facility that's always available. So rather than being fired up on demand, it's just sitting there all the time. And historically, an awful lot of these guys have been running as local system, which is clearly a very, very privileged account under which to run. In fact, some people even run these things under sort of their own user accounts, complete with passwords and all the other fun stuff. So this makes them very, very attractive targets to not friends out in the world who want to go and do bad things to us, like Code Red and Sasa. So the idea throughout all of this work, and I'm sure if you've been playing with Vista, you've seen some of this as well, is the idea of running with the least privilege necessary. You can only use the resources that that service actually needs. So you can't use a service as a backdoor into hacking the system. So reducing the number of vulnerabilities and existing the security model for more granular control. So run with the least privilege, only use the privileges that you actually need for the service to do the job, nothing else. So the service control manager computes the union of all the required privileges for that particular service and permanently removes the ones that are unnecessary. So that if somehow somebody does manage to try and take control of your service, they can't go around getting privileges back and therefore doing bad things. And they can't be added, so the account must support the required privileges. So there you have an example of saying a support in the local service account can't get set TCP privilege, for example. So again, isolation. So as I say, in the past, people have run lots and lots and lots of services under the same account. So you may well find on a system today that 20 or 30 services are running as a local system. This means that there is effectively no isolation between these guys. Any one of them can trample over any other one. And going forward, we want to move people away from that model, whereby everyone has their own unique account for each service. And so each one is treated, if you like a separate user, and therefore they can't go around damaging each other. And this just talks a little bit through how we do that. Again, this is really following on from that. So again, right restriction, only allowing processes with access to objects, allowing write for the SIDs. When the service starts, all services must be restricted. So exactly as it's saying there. Okay, so one other thing we've talked about. Some of you are familiar with the hardware watchdog. This is the thing that basically if a server OS is running and something strange happens and it hangs up, then after a time the hardware will automatically restart. Now, on version 1 of this, which is supported by Server 2003, it's limited to a particular hardware set. There was a particular vendor's chipset. A number of other people have come back to us and said, we would like something more generic. So with Longhorn Server, we've actually added a version 2, and there's a paper up on Microsoft.com that describes this in quite a bit more detail. There's a new ACPI table that allows you to define exactly how your hardware is configured. So if your model doesn't fall into that supported by 1, you may well find that it is supported by the one with version 2. Some of the other points on here are questions that we have been getting generically. For example, as I said, we'll reboot the system automatically if the timer doesn't reset periodically, in other words, when the system's hard hung. People ask, well, what happens if we're in the middle of writing a crash dump? All those kinds of operations automatically disable the watchdog so that if something bad does happen to your system, we will catch as much information as possible before we forcibly reboot it. And that's the case with version 1. It's still the case with version 2. One thing we have been requested a number of times from different people is support for IPMI watchdogs. Now, this is something that's definitely on our radar, but it's not going to be happening for Longhorn Server. It's something that we understand the requests for, but it isn't something that we've had time to do this time around. So there are a number of other areas that I'd like to at least refer to in passing, not least because it gives you a chance to go off and seek some other information. Now, setup has been completely rewritten from scratch. And for those of you who saw Bob Muglia's keynote yesterday, one of the things that he demonstrated was the role management tool for Server. Now, one of the big initiatives that's been going on during the Windows Vista and the Longhorn Server development cycle has been the componentization of the system. Now, this isn't so obvious for Vista and the client space, but for Server it's a lot more obvious. And now we have the concept of roles. A lot of work's been going on in the setup space to minimize the amount of system that has to be installed by default when you very first install. You'll also, for those of you who've installed the thing already, you'll have seen the old text mode setup's all gone away. Everything is now graphical. The user experience is much, much simplified. We also do everything from a RAM disk. When you get your DVD, you'll see that there's a couple of WIM files on it, and these guys get read into memory and installed from there. Also, somebody, I think in one of the sessions I was in yesterday, was asking about Pixie Boot and the ability to install from the net. For those of you familiar with RIS, this has now been renamed to WDS with Vista and Longhorn, and that is also fully supported by setup. So this is the Windows deployment service. Again, following on from that, the setup guys also own this great feature, the OPK and the WAIK, the OEM platform kit many of you will be familiar with. The Wake is the equivalent for people like large customers, folks who may be rolling out 50 or 60,000 desktops and want to do an OEM style install across all of these machines. And again, so basically the Wake is the OPK targeted not at OEMs. And it provides the ability to run all the special configuration and to, for example, go around adding custom drivers to the WIM files that's created, just using the sysprep tool. Now, one of the other parallel threads going on during this conference, and something that you've been hearing about for a number of years, has been the what do we do about WDM and the Windows driver model going forward. A lot of work has been done around the kernel mode driver framework, and this year, I think I see one gentleman in the audience who presented yesterday on the user mode driver framework. Hi, Peter. So this is really moving beyond the Windows driver model that we all know and don't necessarily love into something that's a lot more straightforward to use. Now, some of you may actually be attending those sessions. If so, I congratulate you. It's a very, very fine path to be going down. If not, please read up on this stuff. We're now up to version 1.1 of the kernel mode driver kit that's out there already. I think that shipped about a month ago, maybe, something of that order. And I think the user mode stuff is coming out in beta momentarily. Yes, Peter? In the next week or two. So this is really the move towards trying to get people out of writing kernel mode drivers unless they absolutely have to. I mean, one of the things that we've seen is we've spent more and more time digging into things like OCA, the online crash analysis. There's a number of people doing things with drivers that don't really need to be in the kernel. There's lots of history behind why they are, but there's also lots of extremely good reasons why they shouldn't be. And Peter Wieland there, who some of you may well know back to his days in storage and certainly as part of the Windows Driver Foundation team over the last few years, is leading the team that's actually working on moving people out of the kernel where possible. I know for a server that sounds like maybe a strange thing, but I would strongly encourage you to actually investigate some of this stuff and see whether you're actually capable of moving some of your drivers out of the kernel. So, BitLocker and full volume encryption. Now, Sean briefly alluded to that. This was something that was originally developed very much focused on people with laptops. The idea that lots of people leave laptops on trains, on airplanes, in taxis, and so forth and so on. There's a whole set of sessions on this. Some of you may be interested and you may even be going. For server, this is interesting because a number of people who sell branch office systems are starting to look at this. Now, by branch office, we tend to mean a small box either sitting in a closet somewhere or underneath somebody's desk. And it's becoming more and more apparent how often these systems are disappearing. Somebody decides it would be a really nice box to have at home, and suddenly, hey, all of your corporate data has just disappeared. So we are now working with a number of partners to provide the BitLocker feature on some of those branch office servers. So although it sounds at first as it would be a more client-centric feature, it's actually very interesting in the server space as well. Now, during the little break between Sean's session and mine, one gentleman asked about how this is going to tie in with things like SAN boot. And that's a very fine question. At the moment, it's really not being targeted at the kind of systems that are booting off SANs. It's really being targeted at self-contained branch office servers. So this is when we move out of some of what we have been doing already, and we start to talk about some of the what we could be doing. And the first bit actually comes back a little bit. I mentioned earlier with MSIX why I'd want to come back to this. So one of the things that we've been looking at, obviously, is how do we make things perform better on Windows Longhorn Server? So there's all kinds of performance benefits from running the ISRs and the DPCs on the threads that actually initiated an I/O request. And clearly, as it says here, things like I/O buffer allocation and so on and so forth. The downside of this is it requires the driver performing the I/O to have knowledge of where the I/O was actually initiated from. So at the moment, there's some prototyping going on using MSIX messages to attempt to route the request back to the initiating processor. We are already working with a number of the OEMs around this. We've seen some very impressive performance numbers during testing. I think that there should be, either today or tomorrow, a white paper appearing up on Microsoft.com/WHDC that talks about some of this work. So if we have our sort of hypothetical NUMA system with basically 3 nodes and a bunch of processors, all of which have got, attached memory and attached I/O, there are, of course, a number of best cases. The best case clearly is where the node that initiates the I/O request, or the processor is on the node to which the memory being used by it and the actual I/O device is all locally attached. Whereas obviously the worst possible case is where everything is scattered across these 3 nodes. So you might have the memory on one node, the I/O on another, and the initiating processor as being on the third. So what we've got is that the choices that we've been seeing coming up in order is clearly the best options are that the ISR comes back to the core that initiated the I/O, in the case of multi-core. Next best choice is the processor, then it's through the NUMA node, or the worst case is coming back to the node that contains the host bus adapter to which the actual I/O, the data is connected. So as well as interrupt redirection, we've also got DPC redirection. So clearly the ISR needs to know all about which node initiated that I/O. It also requires support for multiple DPCs per adapter, one per core processor and node. And also there's the whole deal about the memory redirection. Now, as I say, this work is actually going on at the moment. We're seeing some very interesting performance numbers. Unfortunately, the gentleman who's leading that team can't be here today to talk about this more, but he has pulled together a paper which should be appearing very shortly, which you'll be able to find out more about. This is a feature that we would very much like to get into Longhorn Server. I've said future technologies because this is not currently plan of record, but it's something that's showing sufficiently good performance improvements. We would very, very much like to get it in if we possibly can. Now, another thing that came up in conversation with many of you over time is this whole limitation around 64 logical threads. Now, again, Sean briefly alluded to this. As many of you know, for 32-bit servers, we've always been 32-thread limited, 64-thread limited. In the past, this hasn't been such a big deal, but multi-core changes everything. So in the past, we've always been able to say that, scale up on something like an HP Superdome or something like that is a relatively small market that didn't require us to go beyond 64 threads, et cetera, et cetera. However, with 2, 4, and 8 cores turning up, a relatively small, physically small system will soon be hitting that limit very regularly. So consequently, we are starting to investigate what does it take to go beyond. Now, we have done this sort of prototyping in the past, and there's never been enough pressure to really say we should do this. Given where multi-core is going, we are now working to prototype this, to do a complete system prototype of this thing. The bottom line, as it says slightly facetiously, this isn't just a case of changing a hash define from 64 to 128 or something bigger, unfortunately. It's very pervasive across the kernel, as many of you can imagine who've played with those parts of the system and know how much is involved around that. But the work is ongoing at the moment. We're hoping to get a prototype running relatively soon. For those of you who have been talking to the virtualization guys, you know that they care about this a great deal as well. So this is something that definitely is not part of Longhorn Server, but it is something that we're working on. It's something we're very interested in. I have a number of other things that I wrote notes to myself about that didn't actually end up in the slide deck that I wanted to make sure that I spoke to, mainly because I've had questions over time. Now, one of the questions people sometimes come up with is, are we doing anything in Longhorn Server around headless? Have we changed anything? And unfortunately, the quick answer to that is no, we haven't. Everything that you know and love around headless today is exactly the same on Longhorn Server. Nothing's been changed. Sometimes we get requests for things like GUI headless consoles. Now, bearing in mind that the headless runs over a serial port, this is currently not something we have on our agenda. There have also been requests around things like running the headless terminal off something like USB, which is an interesting idea, but again is unlikely anytime soon, largely because of hardware constraints. So for the time being at least, headless is staying just the way it has been. Other areas that I think people should probably go and take a look at if you have time and you're interested is some of the other stuff around driver installation. Now, we've already talked a little bit about the fact that your drivers are going to have to be signed to install on 64-bit. As you know, we've been having a very, very big push around the whole driver install thing. Many of you know about OCA. Many of you know about the issues that we see very regularly. Roughly 40% of our Tier 1 applications actually install device drivers. So this whole deal around getting drivers onto the system cleanly and sometimes off the system cleanly is a huge deal. Many of you may have fought over time creating INF files and all the other fun stuff. Well, the DMI team has been doing a huge amount of work around creating tools to make this task simpler. And if you're interested in the whole deal around installing drivers and so forth, I would strongly encourage you to go to their sessions also. Something else that I have carefully avoided speaking to today is ACPI. For any of you who go around configuring servers, you understand all about ACPI tables and so forth. Now, one of my colleagues, Alan Marshall, is actually doing a session tomorrow. For those of you who look at your little schedules, the acronym under which a number of other interesting sessions are is CPA, for Core Platform Architecture. Now, tomorrow, Alan's doing a whole session about ACPI. What have we been doing for ACPI 3.0 support in Vista and Longhorn Server? So I would strongly encourage you to go along and see his session. There's also, following that, a kernel mode plug-and-play session. Now, this is interesting because it talks about, obviously, all of the aspects around drivers. Now, this is kind of near and dear to my heart now. Some of the work we're doing around dynamic partitioning, for being able to support hot replace, we actually have to be able to pseudo-hibernate the system. As you can imagine, since we've described hot replace as being an atomic operation, somehow we have to be able to stop things like DMA and interrupts. And the way we do this is by actually putting the system into a pseudo S4 state. For those of you familiar with power management, that would normally be thought of as hibernate. And on a client system, that means we'll be writing out a hyber file. However, for this purpose, it doesn't actually write a hyber file because the system isn't really going to go away completely. But it does mean that for many of you who haven't had to worry about things like handling power transitions in drivers on server, if you're interested in running on dynamically partitionable systems, you need to start considering some of this stuff. And again, both the talks around power management and the talks around plug and play, I would strongly encourage you to go and see. Now, right now, I could imagine there's quite a few of you in the audience who are going to sit there thinking, my driver's never going to run on a partitionable system, I only care about small boxes. I would very much believe that by the time we've had another 2 or 3 of these conferences, you'll all be worrying about partitionable systems. I think you're going to see it becoming much more prevalent. So it's one of those things, even if you're not worried about supporting it in the very short term, go along, learn more about what things you are going to have to think about come the time. Other things on my list to make sure that you're aware of. I'm sure you're all familiar with the Microsoft.com site and /WHDC. This is where all of the interesting papers and content that we go around creating for WinHEC and for other events ends up. If you haven't spent much time having a look around there, I'd strongly encourage you to, because pretty much every white paper involving any of the stuff that the people are talking around from the core team winds up there. So, for example, there's a very good paper that basically acts as a sort of a central pointer to a whole load of other material that I'll show you in a moment. In fact, let's just go on to the call for action. So just mention this, go through all of this first. So get used to the idea that server is going to become 64-bit only. Okay? 32-bit is still going to be available for Longhorn Server, and clearly there'll be service packs and hopefully not too many QFEs and all those usual kinds of things to support that. But going forward, there will be no future 32-bit releases for server. So get used to the idea. And think about that if your hardware, I mean, for example, we've had some fun during Vista with certain devices that didn't support 32-bit DMA. I think going forward that if you're producing parts that are still 32-bit focused, that the time will come that you'll fall over this all over the place. For your 64-bit kernel drivers, they need to be signed. Okay, they won't install. For test purposes, yes, you can attach a debugger and you can install it, but for a real live, genuine production system, it won't install. And if it's doing interesting and funky things, which you've got away with in the past, you've now got to contend with PatchGuard, which will watch what you're doing and bug check the system. Now, if you're doing it during testing, that's one thing. If you do that on a customer site, it's a whole different deal, so we really hope you don't. Learn about the many new features available. Okay, well, a lot of that you're going to do by seeing the sessions that you're here for this week, and by reading some of the slide decks for the sessions that you were unable to attend. As I say, things like the Express session, which unfortunately was the first hour this morning, read up on it, understand, is it something that affects you? If you're writing drivers for PCI Express devices, you're almost certain to care about it, and if you're producing the hardware, even more so. We have a number of feedback aliases as well. Have I got them on here? And for the dynamic partitioning one, there's one called DPFB. And most of the sessions that you see, there should be various feedback aliases on. So the DP homepage is there. That's got all of the information around dynamic partitioning that we've yet released. The WHDC System Vista one, that's the kind of collection point that all of the papers being generated by folks in the kernel team end up. So if you're interested around the work that's going on with WIA or with DP, that's a good place to go and have a look. Kernel patching, that's talking about things like the PatchGuard stuff and what will catch you now. So I think that's it. Thank you very much.